Hi, my name is Yecha, and I'm going to go over my book, Unicursal Symmetery. It's a study in symmetry. Basically, I came up with a number system to label points around a perimeter, and my main focus has been 9 because of 3, 6, and 9 being one of my fascinations. So for 9 points, you have a base of 10 that you divide in half for the bottom center point. That'll be 5. And the corresponding pairs that create a corresponding set of numbers that mirror each other add up to 10 across from each other. And so I applied this to other amounts of points. Therefore, 7 added 1 is 8. And so 8 divided in half for your bottom center point is 4. And the mirrored points always add up to 8. And then if you start at 1 and you list the numbers of the points counterclockwise, then you come up with another pattern, which is 1 for the star, 1 plus 4 minus 3, and so on. So it's different for different stars. These are some of the systems that I've used for different numbers. This is just kind of reference, that there's nothing really to do but connect the points together or have your one single point. My primary focus has been to do this to use for math and creating. So that is your hexagons, and I just, build points along in the book just to show artistically, that it comes from one shape and builds up to another. But I go over the formation of these and everything in the book. You have your sharp stars and your dull stars. And for sharp 9-pointed stars, you cross over 3 points to connect them unicursally. And the dull stars, you cross over 1. And the same for dull is with 7, you cross over 1, but for sharp, you cross over 2. And so there's some interesting things there. These are the different ways you can label the 5 points of a pentagon and make a pentagram. 1, 4, 2, 5, and the center point 3 is obviously the prettiest. So in studying this, I came up with these, and I noticed some significance just recently, so I'm going to go over that real quick because I didn't include this in the book. So you have your 3 points, and in between each of those 3 points is 2 points, and I go over that basically these are called horizon lines, and these are called apex points. So the rule is basically you have your horizon lines, your apex point that connects to the farthest point of the most adjacent horizon line. So continuing that, it's pretty simple to see that that's 3 stars, 3 sides, 9 points. So with the square, you're obviously adding 3 more points. So you have your 4 stars, 4 sides, but you have 12 points. And you connect your horizons, and then you connect your apex to the farthest of the most adjacent. And if you see that this is actually 1, and then obviously the horizon lines of the second, because they don't form 1 star when you have an even amount of points. It actually is 2 overlapping each other and rotated to the side. So continuing, you have your 5 points for a pentagon, 2 points in between each. Obviously, you have your apex points there and your horizon lines. And then farthest point of the 2 most adjacent, and continue. So it's pretty straightforward, pretty simple. So you have your 5 stars, you have your 5 sides, and you have 15. Then obviously we're going to go to 6, and that'll be 18. So you have your hexagon, your 2 points in between each. You have your horizon lines, and then the farthest of the 2 most adjacent. So it is pretty straightforward, and it continues with odd numbers of points, even numbers of points. For this, it doesn't matter if it's odd. It's just harder to come up with the actual different progressions that I came up with. So the whole point of all this was to create art. And so this is one of my unfinished pieces that I'm working on. and I go over in the book how to form these different stars that, you know, is obviously, you know, you can create better as you learn, but this, you know, obviously you have your 1, 2, 3, 4,